All right, I wanted to help you get started on your math today. So in Envisions, we are going to be doing lesson 8-1. So when you go onto the main website, you're going to go down to E on online apps. You're going to go down to E for Envisions. Click on Envisions. It'll log you in. Just click on for Google login because you're already logged in with Google. And then select the orange one that says Classes. And then you're only going to do the ones that say 8-1. And then I only want you to do Solve and Share, Virtual Learning, and Practice Buddy 1 today. Okay? So I just wanted to help you get going with that. So a little bit of review. A concept you'll need today doing this lesson is place value. And if you remember from place value, it's the columns where all the numbers go. So we have the ones place, the tens place, and the hundreds. So if I had a number like 351, I would write 351, okay? Because there's 3 hundreds, 5 tens, and 1 1, okay? So your number is 351. So you're going to be really needing to remember your place value during this lesson, okay? Let's go over our standard, our learning target for today. So our learning target for today is going to be I can use place value to understand addition. Okay, and our success criteria is going to be I know I am successful when I can find the sum of an addition equation by using different strategies. Okay, so that's what our focus is today's lesson with 8.1 or 8-1. All right, for the solve and share, I wanted to help you a little bit. Since we can't use manipulatives, I wanted to show you some if I were with you in the classroom. They have 3 cups in the solve and share, and a girl named Olivia has 3 cups of buttons, and there's different amounts in each cup, okay? So for her first cup, she has 2, 4, 6, 8, 10, 12, 14, 16, 18 buttons in her first cup. Okay, so there's 18 in the first cup. In her second cup, she has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 in her second cup. 24 in her second cup. And then in her third cup, she has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 buttons. $22 buttons in her third cup. So these are her amounts that she has in 3 cups, 18, 24, and 22. So they are wanting you to figure out in the solve and share how many all together, the sum all together of how many buttons Olivia has. Now, if I have my math thinking hat on, I want to think about my different operations and the different choices I have to find the sum of all of the buttons together. Now, if we remember what our operations are, remember that anchor chart in our room that we had all the operations. We have addition, subtraction, multiplication, and division. Those are our operations in math, okay? So, if it's saying all together, I want to rule some of these operations out. So I know multiplication deals with equal groups, and these don't look equal to me. There's 3 groups, but each one is not equal. So I don't think we're going to use multiplication today. And the inverse of multiplication is division, and that also deals with dividing into equal groups. We have equal groups, but they're not equal. I mean, I have 3 groups, but they're not equal. So I don't think it's going to be division either. So I'm going to rule that one out. So I'm down to addition and subtraction. So I'm going to listen to the words. They said they wanted the total sum all together of all the buttons. So I know with subtraction, they usually use words like difference, and if one has more than this, or if this one has less than, and they didn't use any words like that in the solve and share. So I don't think it's going to be subtraction today. So we're down to addition. Did you think it was addition right away? Well, good job if you did, because it's addition. When we're adding them all together to get the total sum, we're going to use addition as our operation, okay? So, with that in mind, I know my operation is going to be addition. So 18 buttons plus 24 buttons, plus, 24 buttons plus 22 buttons. I wonder how I can figure out how many total buttons we have. I probably can use some paper to figure this out. So I'm going to start with my first add-in, which is 18. And then I'm going to stack it up this way vertically because I'm going to be able to add it up easier that way. Then my next add-in is 24. And then my next add-in is 22. Put my equal sign and my operation, addition. Now this is where that place value comes in very handy, and we have to pay good attention to it. Because I have my ones place here and my tens place here. Where should I add up first? Right, the ones place. So we always start in the ones column first. So I'm going to look for some friendly numbers that add up to friendly numbers. And my friendly numbers are 2, 5, and 0. So right away I see that 8 and 2, they would add up to 10. And 10 is a very friendly number because it ends in 0, okay? So 8 plus 2 is 10. Then add in the 4. 10 plus 4 is 14, right? So that column, my ones column, added up to 14, but I can't stuff the whole number 14 in the ones column. I can only use the ones from that number, which is 4 there. It's like I kind of break it up, and now I'm going to carry that 10 over into the tens place. It's got to stay with its other 10 friends. So I'm just going to make a little 1 there to indicate that it's another 10 in the tens place now. Now these are all friendly numbers, so I'm just going to go down the row and add them up. Pretty easy. So 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6. So my sum, my answer was 64. So 18 plus 24 plus 22 equaled 64. So what did that tell us? That I have 64 buttons all together, or Olivia does in the problem. Okay, now something that they want you to think about is if I were to move these numbers and these buttons around, would I still get the same sum, 64? That's a good question. That makes me think about the commutative property. We talked about this before. We said commutative property of multiplication. That was when we could flip the factors and still get the same product, just like this. So if I said 7 times 6 equals 42, we could flip the factors, which was the commutative property, and then I could say 6 times 7 also equaled 42. Remember that for multiplication? We dealt with commutative property before. Now we're going to talk about it with addition. And it has to do with the order of the numbers. Commutative property says it doesn't matter. Commutative property doesn't matter what the order of the add-ins are for addition. So if I were to do something like this, Okay, so now I'm going to try the problem with the add-ins in a different order. So I'm going to still start with 18. And then my second number now is going to be 22. And then my third add-in is going to be 24. Equal sign and my operation addition. Okay, same thing. I have to be conscious to keep it in place value order. So in the ones place, I'm going to start in the ones place. And right away I see some friendly numbers. I see 8 plus 2 equals 10. So I'm going to do that again. Plus 4, nice and easy. It's going to be 14. Break that up, ones place, put the 4, carry the 10, 110 up here. Nice and friendly numbers. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6. Hey, that's the same, 64 and 64, even though this order is different from this order. This one says 18, 22, and 24 equals 64. This one says 18 plus 24 plus 22 equals 64. Hey, that is true. The commutative property is true. That if you change up the order, you still get the same sum. So even this is 18 plus 22 plus 24 still did equal 64. Good to know. So that is going to be very helpful to you when you do your solve and share. So just for today to review, it's 8-1. I just want you to do solve and share, virtual learning, and practice buddy 1. That is all for today. All right, thank you so much. Good luck, and email me any questions that you have.